Today we'll be presenting Making and Using Compost Tea by Lynne Carpenter-Boggs and C.C. Crosby of Washington State University. Lynne is an associate professor of sustainable and organic agriculture at Washington State University in Pullman. Her work aims to improve global health and sustainability through biological and appropriate technologies for agriculture. Catherine, or C.C. Crosby, is a PhD candidate in soil science, also at Washington State University. C.C. has led hundreds of pre-nursing students through chemistry and environmental science courses, and she is currently researching the feasibility of composting for new uses in society. So with that, I'm going to hand over the controls of the webinar to our first speaker, who is C.C.
Excellent. Well, welcome to Making and Using Compost Teas. I am C.C. Crosby. We're going to divide our presentation into 4 major topics today. So first of all, I'm going to talk to you about what is a compost tea, as well as how do we use compost teas as a fertilizer. And then I'm going to hand the presentation over to Lynne, and she's going to talk to you about compost tea as a disease suppressant. And she's also going to summarize the uses of compost tea into some nice, clean take-home messages and give you kind of that rundown of what you need to know. All right, so like I said, I'm going to start with some definitions of compost tea. And in its simplest form, we're essentially talking about a mixture that has 1 part of compost to 1 to 100 parts or more of water. Compost teas often contain other things as well, so some people like to add commercial inoculants. Some people will add different things to stimulate microbe growth, including sugars, although just as a side note, if you're adding sugars, you need to be very well aware of the regulations because sugars can increase some of the pathogen growth in compost tea. In addition, people like to add different types of plant nutrients in order to boost the compost tea's use as a fertilizer, which we'll get into again as we talk about fertilizer use. In general, compost teas are going to need to be held a minimum of 1 hour to be considered a compost tea. If you take the same mixture and you hold it for less than an hour, it's considered a compost extract and will be dealt with a different set of regulations. Compost teas can either be aerated to boost their oxygen concentration, or they can be left as what we call a static fermentation. These are also referred to as non-aerated teas. And the goal here is to extract the soluble nutrients in your compost, as well as to essentially allow those microbes into the solution to act on the different nutrients and additives that you put into the compost tea. So here's an example of our passive steeping or the non-aerated compost tea, also known as static fermentation. And it can be as simple as a bucket with compost in it, and as well as those additives. It's extremely low cost. It's a little bit more difficult to keep consistent, and there is quite a bit of potential for it to go anaerobic, which can often mean it's rather smelly. Anaerobic compounds are often fairly unpleasant smelling. In this case, we have the compost tea contained in a strainer to make it easier to get the final product out onto your field, but you don't necessarily have to do that either. You can also brew with an aerator. It can be anything as simple as an aquarium bubbler or something like this 5-gallon bucket brewer that we have shown here. There are also a lot of commercial models available. You can also get aeration simply by stirring your compost tea. So if you're doing a short brew in a 5-gallon bucket, if you're walking by and giving it a good consistent stir every few minutes or 20 minutes or so, you can also get some aeration that way. So our basic goal on the compost tea is to take our compost, get it into the water, and the time is going to allow those microbes to dislodge. It's going to allow those water-soluble nutrients to get into the liquid, and it's going to give you something that you can then get some of those nutrients and microbes into your crops with. And the interesting thing about compost tea is that by changing the way that you brew it, you can actually shift what you see in your compost tea. So if you change the compost that you use, you're going to get a different set of microbes. If you change your aeration time or your aeration amount, you're going to see different communities. And temperature is going to have a huge effect. So if you're looking at trying to brew a consistent tea on your property, one of the things that you really want to pay attention to is temperature. So this could mean that you have a temperature-controlled brewer. It could mean that you brew in a temperature-controlled room, Or it could be that if you don't have the ability to monitor that, that's something that you should really be paying attention to in terms of the consistency of what you have coming out, because it's going to have a large effect. We can also affect what we end up with in our final product with the additives. So here you see pictures of 4 different tea, experimental tea recipes where we use the same compost and different aeration and additives in order to get very different looking teas. So the idea with this is we can take our basic compost tea, and if we change that compost, so if we use more compost, we're going to get a different set of nutrients and microbes. If we use a different compost, we're going to end up with a different set of nutrients and microbes that are based on what was present in that original substance. So some of the most common additives that we see are things like kelp extracts, rock dusts, and these are primarily used to boost micronutrient content. In particular, kelp extract is going to have very high micronutrients. It will also have a high salt concentration, so that's something to pay attention to when you're dealing with your final tea. There's also several recipes out there that call for things like molasses or sugar. Again, you want to be very careful with a sugar source. If you're adding a sugar to your compost tea, you do have the potential to grow E. coli or other human pathogens, particularly if you're using a compost source that has animal-based materials in it. The other things that we see are there's many commercial blends on the market. You don't necessarily need an inoculum to get microbes growing in your compost tea, but if you're looking at a specific reason that you would want that, it's something that you can look into. So in this case, when we add our additives to the same original compost tea, we're going to end up with a potentially different set of microbes, and we're going to have added water-soluble nutrients that are going to change the nutrition components in your compost tea. So these micronutrients are particularly useful if there's a specific nutrient that you know needs to go onto your crop. The compost tea brewing process cannot create an element that's not present in the original compost. It has to come from the additives or the compost itself. It's not going to pick up nitrogen unless that is present in the original compost or in the additives that you put in. And in fact, we'll see in a minute that the nitrogen in compost teas is very low, and the majority of these micronutrients are going to come from what you put in there originally. All right, so here's what we're doing when we brew. We have an original set of microbes in the compost, and we're going to use our brew methods. We're going to use the nutrients, aeration, temperature, anything that you're doing to that compost tea, and you're going to select for a new set of microbes that are going to be present in your compost tea. So the big piece on this is you want to be using the highest quality compost that you can find. If you have good high quality compost going into your tea, you're going to get good high quality compost tea with healthy microbes in it. If you're using an immature compost, if you're using raw manure, if you're using something that potentially has either plant or human pathogens in it, you have the potential to have those be amplified by the brewing process. So it's very, very important that if you're going to use compost tea, you use your highest quality compost that you can find. And we often recommend that you purchase a high quality vermicompost or other high quality commercial compost that you can find the documentation has hit that minimum temperature requirement for pathogen elimination. The other piece is as we're brewing, we can see the growth and the change in the microbial community. So if this is our initial set of microbes in the compost, if we give them things to feed on, if we warm enough and we give them enough time, we're going to see that those microbes are going to grow. If we want to shift what's happening in that microbial community, we can give them food or conditions that are going to favor some over others, and we can actually see very dramatic shifts in that community happening over time. So in this case, if we had had a compost source that was contaminated with a pathogen and we had given that pathogen sugar and warmth, we could now have that pathogen take over the community. The same thing can happen with a favorable microbe. So you want to be very aware of what your brew conditions are. So in terms of inoculants, either in your compost tea or on the field, what we find is that if microbes have a poor habitat to begin with, they're not going to be able to colonize. So here we can see the inoculant happening. You're going to have a very high population from that inoculation. and over time you're going to lose pretty much that entire population until you inoculate again. So you're going to have spikes in population every time you use an inoculant, and if we can fix that habitat, so if we can enhance the habitat in such a way that those microbes are healthy and can get access to all the resources that they need, we can see that inoculants are going to have a bigger effect. So here, after our first inoculation, we don't have a complete die-off of that population. When we inoculate the second time, we end up with, again, a boost in population. And by enhancing that habitat, we can see an enhancement of the way those microbes are going to survive. And this is part of the goal that people are often looking at with compost teas, is you're looking at how do you enhance that habitat, particularly if you have a soil that's very poor in organic matter and microbial biomass in the first place. The other thing that we want to look at is consistency in compost tea. So we know that we can brew different compost teas from the same compost source. So here's a batch of 4 experimental compost tea recipes in which we use the same compost. And on this graph, we're looking at the pH of the finished compost tea. And as we can see, these lines, or these different colored lines on the graph, represent the different batches that we brewed. So these are 3 batches of the same recipe that were brewed at different times during the year. And we get a really consistent pH out of those batches. We also see that the different recipes have significantly different pH. So here we have one with a pH that's a little bit on the basic side. We have one with a pH a little bit on the acidic side. But we have consistency between those recipes, which is really important. And in fact, pH is one of the factors that you can monitor in your compost tea that will let you know if you have some consistent brewing conditions going on. So if you're checking the pH in your compost tea and you're consistently getting a pH around 7, and then you brew a batch and all of a sudden you have a pH around 5, you've probably got something going on that you weren't expecting, and you might want to investigate into that before you use that particular product. So it's one of those pieces that we can look at. We can also see a difference in electrical conductivity. So this is a measurement of salt concentration in your compost tea. And in this case, we have one that has a very low salt concentration. So this was a compost tea with very low additives. Here we have one that had a lot of additives in it, and our electrical conductivity is almost at 2. So this one's going to be very, very high salt. And so we're seeing dramatically different results from the same compost based on what went into that batch and how they were brewed. This is another factor that you can check at home that would allow you to know whether or not your compost tea is consistent. And there's several simple pieces of equipment out there. You can get an electrical conductivity meter. You can also use a hydrometer to check salt concentration as well. All right, so the whole reason for looking at how we could brew different teas is because we can brew a tea to target a need. So the additives that you put in are going to affect the nutritional status of that tea at the end. So if you know that you have a specific micronutrient that your plants are going to need, you might want to choose an additive that's going to allow you to get that micronutrient into your tea. You could also be looking at pH. So if you've got a problem with soil pH, compost tea isn't necessarily going to fix it for you, but it could be one tool in your arsenal that's going to help you to shift that pH over time. We can also use it as a microbial community enhancer. So you've got lots of microbes that are present, that are actively growing, that you can add to your soil. All right, so a lot of the reasons why people use compost teas is because it has the perceived ability to do many different things. We've seen essentially mixed trials on the enhancement in plant health and disease suppression. But we do see a pretty significant use in terms of providing plant nutrients, in particular micronutrients. And there is also some evidence that we might be able to reduce fertilizer requirements or fungicide requirements, which Lynne's going to talk about a little bit later. And there's a lot of research out there that's looking at these different ideas and expanding what other effects might be present. The thing to think about with this is a lot of what we see is mixed results. So in some cases, compost tea will be very effective at enhancing plant health, and in other cases, it will be neutral or potentially detrimental. So you really want to be aware of what's happening in your own system. You might not want to apply to everything in that first trial. You might want to apply to a small patch or small patches in your farm and observe what you see. All right, so in terms of using compost tea as a fertilizer, what we're going to see is it's actually pretty low in nutrition. So here we have these same 4 compost teas that we were looking at earlier, and the one that has the highest nitrogen has the equivalent nitrogen of about 1/2 teaspoon of urea in 55 gallons. So you're really not getting a lot of nitrogen out of your compost tea. If that was your only nitrogen fertility, you'd be in pretty big trouble. In particular, what we're really looking for in compost tea is micronutrients. That's going to be dependent on what you've added and how you've brewed. And we're also going to see some of these other nutrients in there as well. We're just not going to have very high concentrations. So you're looking at very, very low, low concentration. All right, so there are a couple of studies out there that show that compost tea is able to enhance the above ground biomass. And when we apply it to the soil, what we can see is we can apply it in one of 2 ways. We can either apply it directly to crops, in which case you want to watch out very well for your osmotic stress. And you also want to be aware that compost tea is considered an experimental pesticide, and you want to be careful with how you use that. In addition, we can apply it as a soil drench. Soil's more forgiving. It's not going to be quite as sensitive to the salt concentration. The other thing to think about is if you're going to be spraying this, you want to make sure that you keep the pressure on your sprayer low so that it's not going to damage your microbial cells. And you also want to make sure that you filter it very well, particularly if you're using it in your irrigation lines. The other thing to keep in mind is it's a very good idea to dilute your tea with water up to 1 in 100 times. And just a quick note that foliar feeding is actually a fairly effective way to get micronutrients in small quantities into your crop. We've got a few references for you if you would like to take a look at those. And I'm going to hand things over to Lynne at this point so she can talk about regulations and mechanisms.
Great, thanks, Cece. Yeah, so in the last portion of the talk, we'll talk about the use of compost tea as a disease suppressant and some of the research that's been done in this area, and then also get into the legality of using compost teas. Okay, so as Cece mentioned, the first thing we need to say about the use of compost tea as a disease suppressant or for disease control is that this is considered an experimental pesticide, and we are definitely not recommending the use of compost tea for disease control. And even in research, the most significant thing we can say about research so far is that the results are mixed. So yes, there are now dozens of studies showing that particular compost teas have suppressed particular diseases. There are a few studies showing that compost teas have actually worsened diseases. Sometimes we also see enhanced plant growth. And as Cece mentioned, some of this enhancement of plant growth is simply because the compost teas contain some nutrients. There are also some studies showing that compost teas contain plant hormones. So that's another method whereby they might be increasing plant growth in some studies. There are some studies that have shown reduced harvestable yield, as well as some that show increased harvestable yield, and some studies showing that there simply has been no effect. Now, as Cece mentioned, there are many, many different types of compost tea. There is no single one thing that is compost tea. And so it's not surprising that when studies pop up looking at compost tea, the results are going to be really different. And of course, every disease has a different life cycle, and the teas have been used in somewhat different ways. So it shouldn't be surprising that the results so far are mixed. And there really needs to be a lot more work done to before any kind of specific recommendations could be made. So with all of those caveats, I'll say that again, there are dozens of studies showing the use of compost tea reduced or controlled certain diseases. Some examples of those would be late blight of potato and tomato, gray mold on beans and strawberries, fusarium wilt, powdery mildew on cucumbers, apple scab, bacterial leaf blight, and downy and powdery mildew on grapes. And this is very definitely not a comprehensive list, but just as an example, here are some of the published studies. So very few of the studies so far have tried to look at mechanisms. So where we see a positive effect, how might that disease suppression be happening? So some studies are just doing a pure test on effect of the plant. How's the plant responding? A few studies now are really trying to look at why they're having beneficial effects on the plant or negative effects on pathogens. And some of the things that have either been seen or have been hypothesized are listed here. One is simply competition for resources. And this is likely a very common effect. In soils, we consider this the general suppression effect, which basically means if you have a large population of beneficial or neutral microorganisms, it's less likely that any particular population, including a pathogen, is going to really explode because there's simply a lot of competition for nutrients and for space. There can also be predation, and this is more likely to happen in some kinds of compost teas. For instance, if you are culturing a large population of protozoans that feed on bacteria, then that kind of a tea may be more likely to control bacterial populations. There can be direct antagonism, like those that are shown here on the left. These are just known examples of particular antagonistic effects of one microorganism on the other. So this can be through predation or by release of chemical signals, antibiotics essentially, that reduce the population of the target pathogen. There can also be stimulation of plant responses, and we'll go into more detail on this one because it's pretty interesting. And there can also just be interference with the disease life cycle. In some cases, for instance, we see that diseases need to build up to a high population before they turn to a pathogenic life stage of their life cycle. And use of compost teas, again, partially by competition, can simply reduce the likelihood that that population reaches a high level and can begin that pathogenic phase. So we'll talk a little bit more about systemic acquired resistance. And compost teas are definitely not the only kind of material that's being researched and being used to stimulate a systemic acquired resistance in the plant. What this is sort of like a plant vaccination, and you're stimulating the plant response prior to a pathogen attack. Now, plants can release and create many different kinds of defense compounds to protect the cell wall or to break down a pathogen. Many phenolic compounds, peroxidase, chitinase, many different examples. So we can look at what happens in the plant if we apply an inducer material, which in some cases might be a compost tea, but also there are commercial products like Harpins that can induce this response versus a plant that doesn't get that kind of inducer applied. So the blue line is showing a normal plant, and the red line showing a plant that has had this inducer applied. So if there is an inducer applied, basically the plant starts to respond as though it has been attacked by a pathogen. It starts producing some of these defense compounds. So that when there is a pathogen applied, the plant is basically primed to respond. And what often happens then is that the plant that's not prepared tries to produce defense compounds after the fact, and it may or may not be a sufficient response. Whereas the plant that's been primed to produce these defense compounds has a much better chance of actually fighting off the pathogen. And we have a little bit different way of looking at this on the whole plant, and Cece will actually step you through this one.
All right, so Lynn, I'm going to have you do the clicking for me so Alice doesn't have to hand control back. Yes. So what you're seeing here is you're seeing the inducer being applied to the plant. And as we apply the inducer, what's going to happen is the plant is going to take in that inducer. It's going to essentially translocate it throughout its system. And in response, it's going to produce these secondary chemicals that are going to allow it to fight off some disease. So if we now go in and we hit this with some pathogen, what we're going to see is in the plant that has this response, it's going to have the tools that it needs to fight those microbes off, whereas the plant that has not had this stimulation for systemic acquired resistance is going to end up showing signs of the disease.
So again, we just wanted to show some examples and help you to think about systemic acquired resistance, because it's something that is actually being shown to happen not just with some compost teas but other kinds of inducers, and it's something that you can't personally see happening in the plant, but through research we can now see that the plants are able to do this. So now we want to move into a section that's kind of the take-home messages, talk about some of the problems that people and researchers are seeing with teas, and talk about the legal standing and what our verdict on its use is. So there are problems with using compost teas. There's a lot of variability in products and responses. So just like there's no one compost tea, there's no one compost. Every compost is a little bit different. So every tea that you make with compost is going to be a little bit different too. Responses by plants and pathogens are also variable. Some diseases have been worsened, and there are a few published studies showing that, and certainly there have been personal observations of that happening. We have a fairly poor understanding of the mechanisms whereby compost teas can have positive or negative effects on plants, and likewise a fairly poor understanding of all of the different ways that plants and microorganisms are responding to the application of teas. Related to high variability, there just hasn't been great quality control, particularly on farm and particularly for people using it in gardens. So this is something we kind of want to hammer on, is quality control. As researchers, this is something that we strive to do, and as Cece was showing, we in our research we have been able to get to a point where we're tracking the temperature, aeration, compost type, etc., and can make some pretty consistent teas. So it is possible to get better on quality control. Some things that you can control is using high-quality initial compost from a reliable source that uses a consistent recipe for making the compost over time. Definitely, you want to be using compost that has gone through the PFRP that Cece mentioned, the process to further reduce pathogens. any commercial facility has to go through a high heat phase and or using worms to dramatically reduce the pathogen load in the material. And often what the compost that we will use has actually gone through a high heat phase as well as a vermicomposting phase. It tends to give us a really fine material that is consistent. And again, keep track of the other conditions. So what's the water you're using? What temperature is it? Is your tea out in the sun or in the shade? What temperature is it? What are the materials you're adding, and exactly how much? Likewise, even the spray conditions. So you can have the same compost tea applied at different times of the day, may very well have different effects on the plant, as plants will open and close their stomates. If it has rained recently or it rains right after, that's going to affect the potential nutrient uptake or microorganisms that would populate the plant leaf. So being as consistent as you possibly can about how you create the tea and how you use it. Legally, so hopefully we've said this kind of thing enough times. We want to be really clear that compost teas are not currently registered with the EPA as pesticides. Even in research, we have to have an experimental use permit if we use those compost teas outside. We can do work with them in the lab as experimental pesticides. And it is currently illegal to sell any compost tea as a pesticide because there aren't any materials that have gone through the full EPA registration process for pesticides. Now, compost teas can be used to promote plant health. They should not be used for the purpose of treating diseases. So you really should be thinking of these more as a nutritional supplement and a treatment for plant health. The National Organic Program of the USDA has a special compost task force that has repeatedly addressed the use and creation of compost teas. And so I'll spend a couple of slides talking just about the National Organic Program. They define compost extracts versus compost teas. An extract would be held less than an hour, and a tea would actually be held for more than an hour. And compost extracts can be applied without restrictions as long as you are using compost and other ingredients that all meet the NOP requirements for use in an organic program. Compost teas have additional restrictions. So compost teas have to be made with potable water. All of the equipment needs to be sanitized before making the tea. Again, the compost itself needs to be organic compliant. So if you're making a compost tea without any additives, you can then apply compost tea without time restrictions, except that you can't use compost tea on any of the any sprouts. If you're using additives, though, there is a harvest restriction. So the way NOP has decided to think about this, which I think is very wise, is basically if you're using any additives, you need to start thinking about that compost tea as being more similar to manure than it is similar to compost. So what they've done is if you're using additives, they apply the same harvest restrictions as they do for raw manure, which is a 90-day or 120-day harvest ban. If you're applying it to a plant, to an edible portion of the plant, then there needs to be a 120-day period between the application and the harvest. If you're applying it to soil and the edible portion of the plant is not in contact with the soil, then there's only 90 days. So for instance, you can apply compost tea as a soil drench under an apple tree and be able to harvest the apples 90 days later. Whereas if you're growing broccoli, you need to wait 120 days between application and harvest. Now you can do testing for fecal bacteria, and as long as there are no fecal bacteria there and they meet the EPA standards, then you can apply without that manure restriction. But honestly, I don't think anybody is doing that. So each time you make a new batch, make a batch of tea with a new compost, you have to do retesting. And the group OMRI, which is a nonprofit organization, it's not part of the regulatory agency of the National Organic Program and USDA, but OMRI does materials review to see whether the materials would be allowed in the organic certified operations. And they do list 23 different brand names of compost teas and similar materials that can be used even in certified organic operations. But all of those are registered for use as crop fertilizers. There are none that are registered for use as crop protectants. However, they do say that compost teas made on the farm could be used to suppress the spread of disease organisms. But any compost tea sold for disease suppression has to comply with all pesticide regulations, and as I said, they would have to go through the registration process with the EPA. So, what is our verdict on compost teas? What we're seeing is that compost teas do have some nutrients, just not much, so they are a weak but potentially valuable nutritional supplement on plants. Some teas actually contain plant hormones and can give growth boosts or yield boosts because of those plant hormones. Some teas are also stimulating plant defense systems. Overall, we would like to see a lot more peer-reviewed research before specific recommendations can really be warranted. So research is showing that compost teas can provide benefits to plant nutrition and health. Again, EPA rules do not allow use of compost teas to control disease. We highly recommend using high-quality starting materials, because if you put garbage in, you're going to get garbage out. And whether or not you're in an organic certified operation doesn't really matter. I think that the conclusion that NOP has come to is really wise, that essentially if you're using added ingredients and you're going through going through a brewing process, you are increasing populations of microorganisms. And without very extensive testing, you don't know what all those microorganisms are. And so you should be thinking of it more as though you're using raw manure on your plants. So that's the end of our slide set. Now we have time for questions.
Thank you, Lynne and Cece. We are certainly getting questions coming in thick and fast, but I just wanted to tell people that if you'd like to ask a question, you can type a question into the question box on your screen and hit return, and if you don't see that question box open, you can just click on the small plus sign next to the word question to open it up, and we'll try to get to as many questions as possible, although we do have a very large audience, so I'll move on to those as soon as possible. Also, just in case anybody has to go early, I just wanted to remind people that we did record this webinar. I know there were one or two people who had trouble with their Wi-Fi sound going out, so we're going to have a recording available in our archive and on the eOrganic YouTube channel. And if you have a general organic farming question, not specifically about this, you can feel free to use the e-extension Ask an Expert service, and if it's about organic farming, you can type it in and you'll get an answer. We also need your feedback, so we'll be sending out a follow-up survey later today, and so we'd very much appreciate it if you could fill that out. So moving on to the many questions that are coming in. One person made a point that the requirements that were presented were presented as if they were from the National Organic Program are based on NOSB guidance that has not been formally adopted by the National Organic Program. It says organic certifiers have a variety of policies on compost tea use. So if you are an organic farmer, very important to consult with your certifier.
Yeah, definitely consult with your certifier. Yeah, and actually even the statements from OMRI are a little bit different from the NOSB.
Okay. Let's see. What is the effectiveness of compost tea as opposed to just applying compost? Has there been any type of comparison in the research?
Yeah, well, so compost, one difference is compost clearly can't be applied directly as a foliar spray. So compost can be used as a soil amendment or a mulch. And I think one of the studies that Cece mentioned, and you can chime in on that, Cece, was actually comparing compost tea foliar with compost and manure and mineral fertilizers. Mm-hmm.
Yeah, so that's a study on pak choi, and what they were seeing was that both the compost tea, and a mineral nutrient supplement were all providing about the same level of mineral nutrition. What was happening with the compost tea, being able to use that as a foliar spray meant that the timing could be modified a little bit. So if they were having some deficiencies in micronutrients, they could use the compost tea as a supplement that was as effective as the mineral fertilizer. So it's mostly about timing.
Yeah, compost very definitely has many benefits. Compost used on the soil is also going to give you benefits of a mulch, so you'll have moisture retaining benefits that something like a compost tea won't give you, which will only have the small amount of soluble nutrients and microorganisms. So you wouldn't have the as large of the physical benefits or moisture retention as you can get with using compost.
Can you please say more about the idea that compost is considered an experimental pesticide? There were a couple of people confused about what that means.
Compost tea.
Yeah,
so basically, what it means is that as researchers, we're allowed to do research on it. But even if we do testing on a compost tea outdoors, we have to get a special permit to do that. So basically, compost teas can't be used, and no one can tell you to use compost teas as a pesticide. The EPA regulates all pesticides. So yeah, even for the studies that are done, it's considered an experimental pesticide, and we're regulated in the use of those experimental pesticides.
Okay, thank you. I guess there are several people wondering if there are any types of proven formulas available that they can make for specific purposes, or any publications that recommend that kind of thing.
There aren't peer-reviewed recommendations. So all we can do right now is see the individual research studies and what they've been doing. And what most of the studies are doing is using what they feel is a high-quality compost, and doing a brewing process with warmth and aeration, but usually not with amendments. There are certainly some that are using recipes, and we plan to come out with some of our research using these different recipes. But there haven't been enough people doing research with the same recipe that a conclusion can be made from the peer-reviewed research.
We had a question about what kind of diseases have been worsened as a result of using compost tea.
That's a good question. The only one I remember is seeing one on mildew. I think yeah. Do you remember?
So the ones I've seen were mostly fungal diseases that are things like mildew and some of the root diseases, fungal root diseases.
Let's see. Can you discuss the importance of chlorine in water?
Chlorine is going to take out microbes. It's essentially a sterilization agent. So if you have chlorinated water, what you're going to see is it may knock back your microbial populations when you're starting your brew. It's relatively easy to get rid of, particularly if you have an aeration brewer. You can run your aeration on just the water itself for a few hours to overnight, and it should off-gas that chlorine.
Okay. We have a question about whether or not compost tea will harm pollinators.
Will harm pollinators. You know, I don't think I've seen any research on that.
Either.
And just hypothetically, I can't really think of why it would. So, you know, we mentioned that compost tea is often diluted before it's applied foliarly just because of salt concerns. And, you know, again, there aren't solid recommendations on what electrical conductivity or what salt content is a concern for compost teas, but we've looked at the recommendations for irrigation water. And usually below 0.5 decisiemens per meter is a pretty safe salt concentration for irrigation water. But other than salt concentration, which can also be irritating to insects and probably damage some soft-bodied insects. You know, the other part of it is the large unknown of the microbial population. So theoretically, they could have a negative effect if there was something that was pathogenic to the pollinator, but I really don't know that there's been any research on that.
I haven't seen any research on that.
Okay. We have several questions coming in from people who are asking about vermicompost and the difference between, I guess, the liquid that comes out of vermicompost or using vermicompost as compost tea, and I guess what the differences would be.
Yeah. So the liquid that comes directly out of compost is usually called a compost leachate. Or if you're adding a small amount of water and just allowing the liquid to come out and not really going through a brewing and additive process, then it's often called a compost extract. It's not until you go through the longer brewing process that it's usually called a tea. So with the vermicompost, you know, it's using usually Eisenia foetida worms to digest the organic material. Now, different vermicompost operations function differently. The ones that I've seen do go through a hot phase, so a thermophilic short composting, and then feed that material to the earthworms. The earthworms then go through a much more thorough digestion. So vermicomposting, you know, once you put the worms in, it has to be a much cooler process just because they would die in the normal heat of hot composting. And so either with a leachate or an extract, those can be very rich materials. I would definitely be more concerned about potential for high salt concentration, but that can also be seen as a positive if you're applying it as a soil drench, but it's more likely to have a much higher nutrient concentration as a fertilizer. And there also have been studies showing that many vermicomposts do have beneficial hormonal effects on plants, so you can actually get increased growth and yield from vermicomposts versus thermophilic composts or mineral fertilizers.
Okay, well, we have some very practical questions here. Like, for example, if somebody, well, first of all, from somebody who's at home, like if they just want to try compost tea on a shrub in their own backyard, do they need to go through any special approval to do that, or can they just do that?
Yeah, you can just do that. But again, so think about it as using it as a fertilizer and as a potential plant health enhancer, right? Don't use it with the idea that you are going to control all diseases. And also, it is a good idea to do some dilution so you don't risk any salt stress on the plant, and really just be observant of how your plant is responding. There have been a couple of studies now doing repeated compost tea applications, and that does seem to be more beneficial. You're using very low concentrations of nutrients, and so doing very low amounts but repeating that over time tends to be the way people are using it and the way that research is suggesting it should be used for maintaining plant health.
So another very practical question, like if you are going to just make compost tea in a 5-gallon bucket, how much compost should you put in, and what's a good average brew time?
Well, so we can answer that, but so there's no one answer to that that's based on research. So I think that would you agree with that, Cece?
Absolutely.
Oh, okay. So what we've shown are some general guidelines of what people are looking at. So basically anywhere from about 1 part water to 100 parts water in versus one part of compost. The more concentrated mixes are going to give you higher nutrient content and be more suitable for use as a soil drench. The weaker materials are going to give you lower nutrient concentration and be more likely to be suitable as a foliar spray.
I would add also you should definitely think about how you're planning to apply it, because the more compost you add, the more filtration you'll need to do in order to actually get it into your sprayer or into your irrigation lines. So you might want to take that into consideration as well.
Okay, what are the relative risks or benefits of aerating or non-aerating compost?
So the research has not shown clear benefits of doing aeration. Now we can see that the microbial communities are different, but because we know so little about what the best microbial community would be in a compost tea, we can't necessarily say that non-aerated or aerated will be better. Aeration does tend to overall increase the growth rate of the microbial community, but it is also just going to be different. In some studies that have compared non-aerated and aerated, from the ones I recall seeing, and again you can chime in, CC, ones I recall seeing don't necessarily show that aerated is any better than non-aerated.
Yeah, I haven't seen anything that shows a difference in terms of effect between the two. I think it somewhat comes down to preference for what you're trying to do. You could potentially get faster mineral extraction if you're aerating, partly due to the agitation and partly due to that increased microbial growth. And then on the other side, things that are static, the static brew tends to be very smelly. So if you're dealing with the smell, you might prefer the aerated.
True.
Here's a comment that someone wrote in that they've seen botrytis also get worse from using compost tea.
I think the other thing to note with the potential for things to get worse is, like Lynne was saying, there's variability not only within the compost, the brewing process, the additives, but also in the timing of the diseases. So the people who see disease increase versus disease decrease, you might just be looking at the timing of that life cycle, and without having the research behind it, we don't necessarily know what are the factors that are going to cause that to cause an increase in disease, and it very well may be that it's when in the life cycle the tea is applied, because it is applying a nutrient, so you could also potentially be feeding your pathogen.
Okay. Okay, here's a question. Isn't the purpose of compost tea to increase the diversity of bacteria, protozoa, fungi, and other microorganisms? Is this variety of will they supply additional nutrition to your plants? Is that what's working here?
Oh, okay, yeah. So, so that is part of the idea, that you're creating a large and diverse microbial community. Now, what we have some other data, showing that with these different recipes, you are brewing up different kinds of microbial populations too. So the microorganisms do a couple of different things. I mentioned the effect of general suppression and competition. So having a large, diverse microbial population tends to reduce the ability of pathogens to explode in population. It can also stimulate systemic responses within the plant to prepare them for pathogen response. And the microorganisms also do change the nutrient pools. So as the microorganisms are growing, they're taking in the soluble nutrients from the solution, and those nutrients then become part of their bodies. So they can chelate the nutrients. They turn them into organic forms versus inorganic forms. So in terms of so those nutrients do remain fairly bioavailable, but also more stabilized because they're, at least temporarily, in the microbial bodies. Do you want to add to that, Cece?
Yeah, I was going to say the other thing is that, the microbes change the solubility of the nutrients. I'm not sure I have a whole lot else to add, other than if you go back to looking at the slide where we talked about inoculation, when you're adding the compost tea to your soil or to your microbes, there's really no guarantee that the microbes that you're adding are going to survive. It's going to depend a lot on the habitat that you have present, how healthy that habitat is, how full those habitat sites already are with other organisms. So what we're seeing in terms of the research that I've seen on looking at shifting microbial communities in a soil or on plants is it's actually very difficult to shift that microbial community. So you'd have to be adding very consistently to see a small shift.
Okay. In addition to what you just talked about the microorganisms, is there anything else that compost tea does, if you could just review, to reduce pathogens?
I think most of what we've seen is either the competition effect that Lynne was just speaking about, or there can be some more direct effects, but again, with the fact that it's very difficult to actually shift a community on a leaf or in the soil, we really don't know what effects are happening when we do see pathogen reduction. It could be any of the ones that we've spoken to. It could be something that we don't yet understand.
Okay, can you explain a little bit more about what the timeline is to get compost teas approved as a pesticide?
That's not my specialty for sure. My impression is that it's a very expensive process and probably would take a number of years. There may actually be somebody listening who can chime in on the amount of time that it would take.
I think the other thing to think about with that as well is that the requirements for pesticide applications are basically going to say that you need to have a very clear understanding of what the mechanism is, as well as be able to essentially identify all of the active ingredients that are present. And in a compost tea, we don't really have the technology yet to identify absolutely every compound that would be present that might be having an effect, and we're still working on mechanisms.
Okay. How do you know a good quality source to get for the compost tea? I'm sorry, I didn't say that properly, but how do you identify a good quality source? I know you mentioned whether or not they test for microorganisms, for harmful pathogens and things like that.
Yeah. So part of the big question is just commercial versus home production of the compost, and conditions in home piles tend to be quite inconsistent, and home operations don't usually get up to high temperatures for long enough to effectively control pathogens. All commercial facilities do have to go through pathogen testing and through metal testing, and so there's some control and guarantee of very low pathogens in any commercial compost material. But what I would look for overall would be much finer material, so that's going to give you more opportunity to dislodge nutrients and microorganisms. As I say, just as far as the physical material, I find that vermicomposts tend to be very fine and have a very regular consistency. But overall, that's what I look for, is something that I know has gone through the high temperature process and has a fine consistency. Now there also has been some research on immature composts. So this is something that actually people probably don't talk about enough, is that compost can be actually phytotoxic if it's immature. So in composting, there's the hot active phase, and there should also be a cooler curing phase. The microbial community continues to change in that cooler curing phase, and the nutrients become more stabilized. Early on in composting, during that hot phase, the early breakdown of organic materials releases a lot of volatile organic compounds, which can actually be phytotoxic. And there has been one research study with composts of the same material, but at different stages of composting, showing that very young, immature compost, and that would be something that, just by personal experience of it, if you pick up compost and it doesn't smell like stabilized rich earth, if it is odorous, or has ammonia smell, anything like that, that's probably an immature compost. And if you use those materials as a tea, again, in this one study, they were showing that could actually be harmful to the plant. So getting a compost that smells like it's nice and stable, smells like rich earth.
Okay, this is a question about someone who I guess heard a presentation about compost tea 20 years ago, and he was wondering whether anything new has been determined since compost tea is not a new concept. Has there been a lot of research in the last 20 years or so on compost tea, and are there any new conclusions? Or?
So yeah, people have been talking about compost tea for 20 years, but there hasn't been much research, and it's really been much more in about the past 5 years that there are published studies either looking at nutritional effects or effects on pathogens. And so yeah, I would still say that there's not enough to make really solid conclusions, other than that compost tea can be an effective foliar fertilizer. The problem is that even the things that we do know aren't being monitored well by people who are using them. So, for instance, you can use compost teas as a foliar fertilizer. But then you should be doing a nutrient analysis on that tea to know how much nutrient you're applying. And you should have some understanding of the nutrient status of the plant as to whether or not it needs nutrients at this time.
Yeah.
So there still is a gap between before we can make good recommendations for use.
Okay, there are a couple people asking about the use of plant-based teas like comfrey or stinging nettle. Can you say anything about those?
I haven't seen any studies on those.
No, I haven't seen any studies either. Yeah, and I know that that those are out there. Stinging nettle teas are used in biodynamic practice, and yeah, there just haven't been any studies. Again, during the tea making process, those plant materials are going to break down and nutrients are going to be released. Stinging nettle, just as a plant, is very high in silica, and there have been some studies showing that silica sprays are one thing that can stimulate systemic acquired response in plants, but there haven't been any studies putting all of those pieces together as far as making a nettle tea, showing the silica content, and then systemic acquired response.
Okay, here's sort of a general question. Given the variability and unpredictability of results, how can you recommend its use and for what purpose? I mean, you sort of touched on that in your summary there, but do you have any other comments?
Yeah, again, I think that that the guidance from the NOSB is pretty wise in that it can be used as a drench or as a foliar spray. But if you're using any additives, you really should think of it more like a manure. And we would definitely not make any recommendations about using compost tea for the purpose of controlling disease. We're a long way from being able to make that recommendation.
I would agree.
Yeah, it can be used either as a soil drench or foliar, much more as a fertilizer. But on the disease side, I would also say I do really encourage people to make observations and to start gathering observations about what diseases are being reduced or increased, because that's really helpful for researchers if we have a starting place. Again, applying it for the purpose of overall plant health maintenance and fertilization, but make observations about other effects on the plant.
So the one thing I would add to the make observations is the best way to make observations is if you have a section of plants where you haven't applied any compost tea that you can compare that back to. So if you apply it to everything, your observation isn't going to have as much weight as if you apply the compost tea to part of your field and then observe the difference between the part where it's been applied and the part where it hasn't been applied.
Okay, I think we have time for one more question here. Do you have any equipment recommendations for brewing a couple of 100 gallons at a time, like 200 to 500 gallons at a time? And if you do that, is there like an expiration date for the compost?
As soon as you stop aerating, your microbial community is immediately going to start changing. So it's definitely something that you want to use as quickly as possible.
Okay, do you have any equipment recommendations for brewing large amounts at a time?
No. I mean, I would envision that happening in something like a stock tank with a pump for aeration. Yeah, I mean, and I know that there are commercial models that you can purchase. We certainly don't intend to make any, and as university employees cannot make any particular brand recommendations.
Okay, well, thank you. Thanks everyone for all your questions, and we are running out of time, so I'd like to encourage you to check out our many upcoming and archived webinars on organic farming and research topics at the link on your screen. So thank you, Lynne and Cece, for sharing your research with us, and thanks to everyone for joining us.